Alright, we're just going to try to stream again for a little bit and see if it crashes again. We will see. Alright, so one thing I think would be cool, we were looking at where the heck did LeetCode even go? Where did LeetCode even go? Oh no, we were looking at this. So this is compiled with Clang. So when I compile code here, uh, I'm using the MSVC compiler, but what would be cool is if I have Clang. Do I have Clang? Okay. Okay. I know I set this up at some point. Hmm. Ooh, whoa. That's a lot of stuff to dump out to the command line. Maybe I should have done that to a file. Whoa. It overflows my buffer here. Okay. It's not totally what I was looking for. Verbose version, print version information. But when I did that, didn't tell me. Oh, I'm just not looking closely. So it's Clang 12. So, okay. So if we do like, well, let's see if we do. I don't know enough to do this a different, like, from the command line to like just like delete everything except main.cmu. I'm sure there's a smarter way to do this from the command line. Okay. So if we do Clang, hmm. Hmm. Okay, how about we exit this just to make sure any kind of anything like configured is cleared out. Have a fresh terminal session. Oh. We're gonna skip. Okay. So I'm using Clang, but somehow it's yeah, somehow. So I wonder how you update this. I wonder. Mm, not gonna mess with that. Hmm. Yeah, tonight we were kind of like going everywhere. We were gonna look at can you use SIMD on LeetCode. Now we're just looking at LLVM stuff. Okay. Interesting. Hmm. Oh, that's not what I wanted. Okay. So I could uninstall that. We will uninstall that. Sure, there's some fancy way. I don't want to do all this. Where do you download? Hmm. Hmm. Here we go. Releases. So should we just get the latest? Eh. Always such a tough decision, right? We shall get the latest. Even though this won't be identical to what LeetCode, we will get the latest. There's a lot of stuff, my friends. I saw the Windows one down here. Do you want the Windows one? Is there like a Windows installer? So far, OBS is not reporting any issues. Okay, so let's see. Right. The computer is heating up though. Windows is trying to warn me that they don't know who the publisher of this exe is. I agree. Do I want to add it to the path? Couldn't find it. So I must have had it in the path. I'm going to add it for the current user. I like that spot. Cool, 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 cool. While that runs, let's do some. Let's take a Twitter break. Hmm. Kind of has Horizon Zero Dawn vibes here. Kind of looks like Winston from Overwatch, like a Horizon Zero Dawny Winston. Pretty cool, pretty cool, pretty cool. Wait, I saw a comment here I want to see. What is this? That's cool, that's cool. Cool, 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 cool. LLVM is finished. Alright. So if we do restart my terminal here. There's something I saw in Hacker News. There's something I saw in Hacker News the other day that I want to check out, and it was no. Isn't there somewhere where I have like favorites or something? Favorite. Pyrite, static type checker for Python. This seemed kind of interesting to me because I always get annoyed working on Python. Oh, it comes as a VS Code extension. Okay. Okay. I want to try this out when we revisit some Python render doc stuff because I don't know. I always get annoyed with Python and not having types. Alright, but we should have. Yeah, alright. So we do. Okay. Hmm. I always type 0. It's supposed to be O. Okay, but how do you get this isn't generating a PDB. So let's see. Let's try something here. Let's try clang help. Cool. So no results there. So let's see. Wow. I did notice. Yeah. LeetCode uses address sanitizer. I should probably look into that. G, generate source level debug information. All right, I think that's what we want. I saw that in passing in a Stack Overflow, like when we Googled it, I kind of noticed it. That took longer. Okay, now let's try one other thing. Let's add V so it's verbose and see what it does. Oh, okay, that did a lot more than what I wanted. Okay, it's still kind of nice that it tells you this stuff. Okay. Okay. So now let's see if that works. Okay, this should be not working because we don't have a main. Wait, how do you name? So we're just getting a.exe. Like, how do we name it? I don't know how that works with okay, dash O. I don't think you need the F. I can just say, whatever. Cool. All right. And then, so can we do div inf? Can we use? Oh, okay. So the reason this is happening here is because we haven't initialized MSVC. So if I have this alias configured to do that. Now I'm curious if for some weird, like if for something about doing that messes up doing this. So let's try. Okay, let's do. Okay, so that worked. Okay, so now we should be able to do this. And I mean, I don't know enough to know, so that's why I'm asking. I'm having to check. Is like, can Visual Studio debug when it was compiled with Clang versus MSVC? I'm sure it can. I don't know why I would wonder that, but that's me asking the stupid questions. Cool. Yeah, it works. It's optimized away, not available. I wonder if there's a ZI. Is there a similar option as ZI or Z7? Yeah, it optimized away that function there too. Can we see? Here, let's run that again, and then we can look at the disassembly. So that's cool, and we should be able to step through each line of disassembly. Oh, So it looks like it just put all that code right here. Neat. So that's using Visual Studio, but I really like using I kind of showed it on last night's stream, but I really like using Remedy. So it's a debugger. I can add my source file, and it can see disassembly. So it's got all the disassembly. Although the one nice thing about the way Visual Studio is doing it is Visual Studio had like it had the it was disassembly inlined with the actual code. So style. I wonder if there's a way to do that. Hmm. I don't know. It would be kind of that would be kind of neat. Uh, so now I'm kind of thinking I like Visual Studio because it has it inlined. So we're gonna go back to Visual Studio, my friends. Okay, so we can got memory here, registers. So register R8, we're saying we're gonna move whatever is at this spot to this spot. Looks like it's some kind of pointer. So R8 contains a memory address. So if we take that, looks like there's, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let's do 16. All right, then they're gonna move the word test. Wait, what? Oh, then they're gonna move pointer to test to R14. So I'm guessing like R14 should get, if we go to test, let's see, wait. I don't know what this does. XMMO. That's a little bit beyond my knowledge right now. What register is this? And it's not showing me, but test has a memory address though. We know this. It has to. Everything has an address. So if we do test, which can I make the size? I was going to try to increase the font size for this, but it doesn't work. Here's its address right here, right? Why can't I get the value? Copy. Okay. Either way, we're expecting this to show up in R14. That's what I'm trying to. After we hit step, I'm expecting this number, which is the address of the vector test. I'm expecting that address integer to be in R14. It's not. Whoops. I was overconfident there. I wonder why it's different there. One D. Yeah, it's definitely not the same thing. All right, one other idea is haha. That's the pointer. All right, so what it moved to R14 was the address of the first string, ZYX. Yeah, that's neat. And we can and when we punch that into the memory, we can even see it right here. Too bad that it's so small. The font is like. All right, hold on. There's probably a way to debug in Visual Studio Code, which is what I actually like using. I'll figure that out for another stream, though. Yeah, I'm not messing with that. Not messing with that tonight. Here, just increase the size of this. Anyway, so we figured out that that in this line here, what it did was it moved the address of the first string. All right, then what it's going to do out here is it's going to take the EDX register, which is this register, but it's like the lower part of it. I think it's like the EDX is like half the RDX, and it's gonna OR it out. It's gonna make it all zeros. That's what this line is gonna do. Oh, it actually ORed out the whole thing. So that's interesting. I guess it's automatically extended. Okay, whatever. But it cleared out that register, and then it's going to subtract R14 from R8. Which R8, what has R8? R14 has the address. What is on R8? 498379. Okay, so these are only different. It's going to subtract these two. I think what this is doing is it's getting the first character, right? Because we could even the only thing that's 7937A50. It's this A50 that's different, right? There's nothing in there. Alright, well, let's see. I think this means subtract R14 from R8. I think that nothing happened there. Oh, wait, no. No. 60. Well, 60, which is, well, it's just the difference. Yeah. It subtracted this address from this address and stored the result there, which is that. Okay. And then jump if equal main. Let's see. Oh, that's probably this line. So main is probably a pointer to the beginning. So if we do main plus this, there should really be a number there. There is. Jump is equal. Well, let's just didn't. I bet if it had been 0, it would have. Here, let's try it. This is painfully boring, I'm assuming, for anybody watching, but I'm pretty curious now. If, let's say we didn't do any of this. Right? We went back and we compiled. Ah, nuck and futz. We gotta do this sooner. Uh-huh. Oh. Okay. Hmm. I think it just like doesn't do anything here because it can see that it's an empty, because it's optimized. So yeah, since it's optimized and it can tell that this is 0, it doesn't even go. It just like compiles that out. So okay, yeah, that's fascinating. So you didn't even really need that. Is that right? Like, You didn't even need the code to check if the string is empty because it didn't even go, it didn't generate any disassembly there. That's interesting. I wonder though if that's like behavior you can rely on. But we kind of talked about it before that code doesn't really, like having this check right here doesn't really mean anything because like these loops only work based on the lengths of this, well, yeah. Okay, this one. This is where it could be tricky. All right, this one right here is fine, but if we didn't have this check here, this is the one. This is the one. So if we wanted to, yeah, so if we completely did away with this, we're not guaranteed to be safe because of this right here. However, what we're seeing in the disassembly is that if this string is 0 length, if this vector is 0 length, it doesn't even generate the code to call that function. So, if it's optimized. But I don't know if that's like something you would want to rely on. So, that's cool. That's cool. That's cool. That's cool. That's cool. That's cool. All right. I think instead of stepping through the remainder of this disassembly, it's time to play Fortnite after a short break. BRB. I know I said I was going to BRB and play Fortnite, but I can't help myself from looking at this code. Now we get all that. Cannot move execution to this location. I wonder why not. I am curious about... Okay, so here's where we're moving something into R8. And then here's where we're doing the subtraction. What is in RBP? Oh, that could be... When you call into a function, there's calling conventions. This may be related to calling convention? Doesn't make sense. We would have to figure out like what's here. So if you do RBP, so RBP is some address, I think. And we're subtracting, what is 18H? What is 18 in isn't that like in 24? So it's subtracting 24 from there, right? R8. So what we expect here in R8, where are you, R8, is what's here minus 24. Well, let's get what's here. So if we take that, we're expecting this to show up in RBP, or to show up in R8. So R8, that's not at all. That is not at all. So maybe I'm wrong. Like, I don't totally know how to read this. That's what I'm saying. But remember when I think this is actually fetching a value and putting it in the register. Which could have been the value in that register. The value here could be a thing. All right. So let's place a breakpoint right here. And stop. Yeah. Can't place a breakpoint in the disassembly, unfortunately. All right. All right. So if we take RBP, right, we put it here, and we do minus. Okay. We take RBP. We do minus. We're expecting this address here. Hmm. Hmm. Yeah, I have no idea what I'm doing. We all know that. Oh. I wonder if I can't go back there because it can't. Like if we take this, let me see. Can go back there. Okay. Hmm. I think this just means subtract 24 bytes. If this is a byte and I'm at 16, wouldn't that just be, right? Wouldn't we just be going 16, 32, so 32, so 16. We start here. This is 16 because it's like that, right? 16, 17, 18, 19, 20, 21, 22, 23, 24. So are we expecting this to show up in R8? Let's find out. News at 11. Nope. Mm-mm. Well, unless we had the wrong thing. So 16. Wait. Maybe? Yeah, I think so. So RBP is this address right here, right? Yep. Which is right here. So 16. Right. 16 gets us to here, and then so then to get to 24, we would be like 16, 17, 18, 19, 20, 21, 22, 23, 24, which should be halfway between there. So then because of it, like because of how you have to read it, the value that is here is 207C 90ED A3 01 0000. Yeah, so you read it this way. So it did move that value to R8. Okay, so that's probably some kind of pointer, which, well, no, that is a memory address. So then if we take this here, so it moved the value that was at this address, moved that into the register 8. And so if we take this address off of register 8, punch that in here, there's nothing here. There's nothing here. Okay. But then we're going to move the first letter of the, we're going to move the first string in R14. That's not true. we move the address of the first string. Yeah. And this is the part I don't understand. So this is the part that I don't understand. Oh, remember? Yeah, okay. So R8, there's just 0 there, right? And my code is checking if it's if the size is equal to 0. And so probably what it's like is probably if there had been nothing here. Okay, EDX. Well, let's just keep going. EDX becomes 0, and then if we subtract this address, from this address, we're going to put that in R8. So R8 is going to be, we're going to do R14 minus R8 and store it in R8. And then we're going to say jump yeah, so JE does a thing. I think that means this generated something completely different. Have I been on mute? Jeez, I hope I haven't been on mute. Alright. By the time you're wondering if you've been on mute, it's time to stop. Why did I even come here? Oh, I just wanted to see what JE. JE checks if the status flag important forms. Yeah. So what this is saying right here is like it checks a condition flag, which is probably like this right here. And if the condition is met, it probably jumps back to main. Six seven BD 5 BD5A. Right here. Yeah. So what this is telling us here, this line of code corresponds to this, which could just look there. And it's just saying jump equal to, which if we remember from Godbolt, JE means checks one of the say EF flags register. Okay, a condition code is associated with each instruction to indicate. All right, so yeah. This is checking this EF flags for some kind of condition, and if true, or if that condition is satisfied, then it will jump to main plus 15A, right? And it gives us the address right here. And so we can notice like that address is basically the same as this except for the BD5A. BD5A. But if we scroll down, we can see that BD5A is right here where we're doing the C out. So anyway, so we figured out what the first 5 lines of this code did. And I am going to call it a night at that. The next few nights, couple streams, we can finish looking through the rest of this because this is something I want to be better at. And some questions I have right now are like, what is this? What are these registers? I think these are like if I'm not wrong, these are like registers that you can do SIMD stuff on. So like our strings, our C++ strings like already in these registers, and we could just use them without having to worry about the byte alignment. I mean, it's possible, right? Because if we go back here and we do this, oh, if we go here, one thing to notice is like here where it's doing, here where it moves the address of the first string into R14. I mean, that is 16 byte aligned because this whole first thing is all zeros. And this is hexadecimal, so that's 40. That represents 4 zeros right there. 1 0 represents 4 zeros in hexadecimal. So that the beginning, this string is at a 16 byte aligned address. So like if we go here and we do watch and we do and test 1, also 16 byte aligned. So it could be looping this all the way back to where we started on this big journey tonight. It could be that we don't have to worry about this 16 byte aligned stuff because the strings are already 16 byte aligned. So that is cool and means that I want to come back to this again and see if we can't use SIMD on this LeetCode problem, which we can just try, right? Like, nothing is going to get hurt if we just try it. So if we go back to LeetCode, how do I get out of here? How do I get back to like close? All right, we got that. Right. Let's just go wild here and do I don't know what 120 M1 G8I. Oh, that's probably saying use it as a integer instead of a float because normally this stuff is float. Well, in in some situations this stuff is slow. Let's just, and we're gonna do some of this stuff. So we're gonna do const. They're gonna so they're loading a pointer. I should do more research on this because like I'm trying to copy this line of code and I don't. Source is already a pointer. Saying const pointer. I kind of understand what's going there. Let's just see. Yeah, it has to be a pointer. Let's just try doing. We should be doing this on Godbolt, but I think. Okay. You've attempted to run the code too soon. We should do Godbolt and make sure this compiles first. Huh. That did compile. Alright, so that tells me that theoretically we could use this on LeetCode, but I don't actually know what this does, so I guess for the next streams what we can do is, you know, actually figure out how to use this SIMD code and replace this. One thing that will be a potential problem is like does this fit the whole string in there? I don't know. Lots to learn. Worth pursuing, I think, because we get to step through some disassembly, and we also get to see if we can get this to work. So, cool. All right. Well, you know, tonight was a troubled stream, but it's cool. All right. Should I go? Should I stop or should I play Fortnite? Okay, we are going to play Fortnite. Okay. No more teasing. I want to keep this. I'm going to document this. I want to keep this link. I want to like get the link here. Gosh. Just getting these links so I can close it. Cool. Alright, let's close some more stuff before we go play Fortnite. not gonna close all those. Can close this. I can close Steam. Uh-oh, looks like. Alright. Alright, we are